Greetings, SHSATers. So we're going to continue the 2022-2023 SHSAT Handbook Review. I'm in Form B, and we're going to start with question number 84, which deals with rates and proportions. And depending on how much we can squeeze in here, we might also talk about the constant of proportionality. If not, I'm going to spin it off into its own video. All right, so let's jump into it. An athlete runs, let me get my tablet set up here first. Okay, there we go. An athlete runs 1/8 a kilometer in 3/4 of a minute. So already I can see that there's a rate, and it even says at this rate. Which rate? 1/8 of a km to 3/4 of a minute. And I also have my math radar going off saying, are they going to ask me to do a unit conversion of either the meters or the time? Maybe to seconds, maybe to hours. I don't know. And then it just ends up with how many kilometers would an athlete run in 1 minute? Okay. So basically they want to know what that's equal to. That's all that's going on here. There's other ways to set this up. I can talk about those. But let's solve this. So I like to take this as just the standard something divided by a fraction. So we have 1/8, and I like to write it out longhand, divided by 3/4. And this is our scenario where we multiply by the reciprocal. And if you're, depending on keep, change, flip, you keep the original fraction, you change the sign from a divide to multiply, and you flip that. And at that point, we get 4/24, and that's equal to 1/6. If you wanted to, you could take this 4 and cancel it into itself, and take that and cancel it into there, and you would still get 1/6, right? So the answer is 1/6 F. Okay? There's another way to approach this division, which is that I noticed that the denominator here is 8ths, and that's 4ths. So what I'm going to do is just multiply this whole thing by 8/8. So I'm going to take the original fraction and multiply it by 1, so I'm not changing anything. And look what happens. I have 1/8 times 8 as the numerator, so that gives me 1 because the 8's cancel out. Or I get 8/8 and it just becomes 1, right, on the numerator. And the denominator, I get 24/4, which is 6. Or I can just notice that this 4 cancels into here, and I get that. So this becomes a way to kind of do this fraction in your head. I'm a guy who keeps saying to write down all your work. But once you write this down and multiply it by the 8/8, it's pretty clear this is 8/6. You could just do that. You don't need to necessarily do this busy work here to have gone through that. Now, there are other approaches to this, which is that if it's asking how many kilometers would the athlete run in 1 minute, by the way, my initial concern of do I have to do a conversion from minutes or kilometers, it was not asking that, so I did not need to worry about that. And in a lot of cases, rate questions can be set up as proportions. How? How can we do that? So let me change the color just to make sure I'm kind of solving this an alternate way. One way is to just set it up the way I originally did it. I have 1/8 of a km is to 3/4 of a minute. Okay, and then they're asking us how many kilometers. So that's x kms, right? Over, and then it'd be 1 minute. So 1 minute. Okay, and if I do the cross product of that, I'm going to get 1/8 times 1 is equal to 3/4 x. I want to get x by itself, so I'm going to multiply both sides by 4/3. Right? This cancels, that cancels, and I'm back to my original thing over here. I can either get 4/24 or cancel these out here. 4 goes into that twice and get 1/6. So no matter how you slice it, I'm still getting that. So here we have a proportion followed by the cross product. It's still going to give us the same answer. If you want, just in case you did a computational error, it's probably worth doing it the two different ways. Again, I'm a person who's also strong in solving questions alternate ways as you double check. Um, Usually I find that double checking is important, don't get me wrong, but in enough cases when you do the double check, if you made a mistake the first time, you're probably going to make a mistake the second time, especially on a test like this. Your adrenaline's flowing and you're not 100% in the right mindset, if you will. Um, and by the way, that's part of this. Your process is to be ensuring that you can get some of these right. So let me change the color one more time again. What's a good color here? Let's go with the fuchsia. The fuchsia always wins. So if we envision this as the distance equals the rate times the time, right? And as a sidebar to that, we also have rate is equal to distance over time, right? And then time is equal to distance over the rate, all right? So in this case, it's actually the rate we're trying to figure out. But if we plug the numbers in that they gave us, they're telling us that 1/8 of a km is equal to, and we don't know the rate. That's what they're asking us for. How many kilometers would be there versus the time? Okay, and the time in our case is 3/4 of a minute. So to solve for r, like I did in the circular version here, we would have r is equal to the distance, so that's going to be the 1/8 km over the 3/4 minute. And if you notice, that's what I originally wrote here. So I originally wrote this without knowing the formula because it logically followed if it's a rate, it's something over something, and they're saying it was kilometers per minute, right? So that's all I did here. The other strategy to do this was if it was 1/8 km equals r times 3/4 minutes, I could just multiply both sides by 4/3. That cancels out. This is times 4/3, and we get back the same thing here that we keep getting, which is 4/24, right? So no matter how we slice this, these are alternate ways to do this and approach it and think about it. This was an easy question. So that's 84, 86 is a little more involved, but let's give it a look-see and give it a run for its money. So it says birdseed mixture is 2/5 sunflower seeds. So that means it's 3/5 something else. We don't know if they're going to tell us what that other thing is yet. The cost of the sunflower seeds is 10 cents per ounce. That's a rate. Okay, it's 10 cents per 1 ounce. I always like to put that unit down, just so because when I cancel units, I don't want to be left with nothing at a denominator or a numerator. Okay, so we're up to here at this rate. So again, like I said, it was a rate, even though it said it was a cost. It's a rate, 10 cents per ounce. So I have 2 ounces, I have 20 cents. If I have $2, I have 20 ounces. All right. So at this rate, what is the cost for the sunflower seeds in 25 pounds of the bird seed? So in the other question, I was worried about a unit conversion. It didn't happen. In this question, I'm still worried about a unit conversion, and it did happen. All right. So there's kind of two things we can do here. First of all, they tell us a pound is 16 ounces. So if we want, we could just put that down here as a proportion and set it up. So what we're trying to figure out is what would the price be here? All right. Obviously, it's going to be times 16. That's times 16. That's times 16. So we're going to get $1.60 for a pound, right, per 16 ounces. All right. So then it's asking us, what is the cost for 25 pounds of the birdseed? Well, if it's $1.60 per pound, right, and it's 2/5 of the 25 pounds. So we want to get that. 2/5 of the 25 is the same as 2/5 times 25. That cancels, so we get 5, right? And that means we're only worried about 10 pounds of the sunflower seeds. Again, we don't know what other parts is in there. Okay? So if it's 10 pounds and it was $1.60 per pound, then obviously the answer is $16. Okay? We could have also set this up as a proportion. I kind of set up my initial rate here and then just ran through the logic and each step as each sentence went along. If we set up as a proportion, let me change the color here. Let's go with green. We'd basically have the 10 cents, okay, is to the ounce, right? And then they're asking us what would be the price, if you will, at the 25 pounds. Now that isn't quite it, because we have to do that conversion to get out what we did over here. All right, and I applied that was what they gave us here in the note. 1 pound is 16 ounces. So if we write that times 1 pound, 1 pound is to the 16 ounces, right? And then we can get to be able to solve that. So basically what we're going to get is x over, and I believe that's 400, right? Instead of going to the side, I'm doing 25 times 16. Okay, what I did was I multiplied in my head this times 4, and got 100. Okay, and that means if I have A times B, if I do something to A by a multiplication, I can decrease B by a division. So what I'm going to do is divide this by 4 and get 4. So I changed 25 times 16 into 100 times 4. So I got 400, okay? So you want to use your numeracy for some of these. If you don't know that rule, I would suggest that you do 25 times 16 and then do 16 times 25, just to make sure you're getting that out right. In the event we have a new proportion now, which is, just to be clear, we have the 10 cents, which is basically just the 0.1 over 1 equals x over 400. Okay, we do the cross product. We get 400 times 0.1, which is just 40, equals x. Okay, that's G. But remember, this is based on the 25 pounds. So we still need to apply the 2/5. So we get 40 times 2/5. That goes, and that's 8. So we get 16. By the way, if you notice, I personally prefer to do canceling out as much as possible. It just makes the multiplications easier. All right, and then we get 16. So we solved it by setting up an initial rate and then just going through the sentences as it led us through it. I also solved it by setting up a proportion, doing a unit conversion right here, and then getting the price per the whole thing. But we know it's not the whole thing, and then prorating it down by what they told us it was prorated down by. Okay. There's other ways to solve this by using the 3/5 part and subtracting it off. I don't see that that's helpful at all here. So anyway, this problem was a little deeper than the traditional rate example, because you have to do that extra step to it. But that's pretty much the spiel on that. So that was 86. The next is 87. So again, a lot of these can be solved with the rate and with the proportion, and depending on which you kind of prefer is kind of the way you're going to go there. So let me just bash on these with that same kind of thought process and logic to them. A robot moves forward at the rate of 9 steps, and I like to write these things down, every 6 seconds. Okay, so it's 9 steps per 6 seconds. Seconds. If each step is x feet long, what must x be in order for the robot to travel exactly 270 feet per minute? So I can see already, if I want to, if I make the denominator here 60 seconds, that's a minute. I'm multiplying by 10, so that means there is 90 steps, right? I took the rate they gave us. This is the same rate, 90 steps per 60 seconds, okay? And that means that's equal to 90 steps per each minute, okay? So it seems to me that if it's 90 steps for each minute and they're trying to look for 270 feet, right? Then that conversion needs to be 3, because what we basically have is it's the steps times that x, right? That's kind of a critical thing here that's happening, right? Right, we got 90 steps. If each is 3 foot long, we're going to get 270 feet out of it. So we basically have 270 divided by this 90 here, okay? We could have set this up as a proportion too. So I started out with a rate here and just used logic through it. So again, we can solve it a slightly different way. It's still underlying really the same way, but if we took the 9 steps, and each one has a multiplication of the x feet, so it's going to be 99 steps times x, right, over the 6 seconds, right? We want to set that equal to something, which is the 270 feet over 1 minute. All right, and at that point, we can just solve it the same way we did above. There's nothing else magical going on here. Again, if I multiply this, if I do a unit conversion, that 60 seconds is 1 minute, right? I'm going to multiply this here. Then the seconds cancel, and the 6 goes into here 10 times. And this becomes 90 steps per 1 minute, which is what we wrote over here, equals the 270, times the x, the 270 per minute. And then it's obvious at this point that it's divided by a minute, so that can go away. And we just basically have 90x equals to 70, and the x is equal to 3. And everybody lived happily ever after. So this one wasn't too bad. You can use rate, you can use the proportion. You can really just even use logic to get through it. It wasn't too bad. Okay, so that's 87. 88. There's 36 people at a party. Awesome. Okay, not a big deal so far. If each person at the party drank 2 cups of juice, right? So that means there's 36 people. They each drank 2 cups. So 72 cups was what they drank. How many gallons of juice did they drink altogether? So again, they give us the conversion here. All right, so if a gallon is 4 quarts and a quart is 1 cup, then a gallon is also equal to 16 cups. right? We're just going to multiply by 4. So how many gallons of juice did they drink altogether? Well, it's basically asking 1 gallon is to 16 cups, as how many is to 72 there. All right. And once we go and figure that out, we end up getting basically 72 over the 16, right? Because we can get x by itself by just multiplying both sides by 72. So we have 72 times 1 over 16. Okay, and if we want, we could actually do that division, or we realize 8 goes into both of these. So we get 9 over 2. All right, and that's 4.5. 4.5, 4.5. So we get F out of that. So this one wasn't too bad either. There's not much other thing they're asking to do with a lot of these. So again, you can just set up the rate, do it through logic, or you can set up the raw proportion and figure that out as well. The next one is 89, but I think I did that already. Yes, I did. So go look at a previous video. I'm guessing it's the first one that I did for the multiple choices, because I was doing a lot of arithmetic examples in there. And this one kind of was just too obvious, so I just threw it in as one of them. I hadn't looked at how many rate questions there were at the point. So if you want to throw in 89 here, you can. That's the solution. Stop the video, look at what I wrote here, or go actually find that other video. So that's 89. And then there's 91. So where's 91? And 91 is just more of the same. So it says a recipe uses 2/3 of a cup of sugar for every, right? For every, that's our keyword. We have rate 1¼ cups of flour. 2/3 cups of sugar per 1¼ cups of flour, right? Miles per hour, sugar per flour. So let's just set up that rate. 2/3 a cup of sugar per 1¼ cup of flour. Okay, is there going to be unit conversion? Let's see. A cook wants to increase the recipe. How many cups of sugar are needed for each cup of flour? So again, this by itself is sufficient. All right. So if you want, this is the same as 2/3 over 5/4. All right. And that's our usual 2/3. Again, write it in longhand. Divided by 5/4. That's the same as 2/3 multiplied by 4/5. And that's 8/15. And that gives us A, and we're done if we want to be. If we wanted to, we could have set up this as a proportion. We could have done 2/3 over the 1¼ is equal to how many over 1, because that's what they're trying to shoot for there. All right, and just solving it that way. Let's see. And I guess we could have also taken even this here in the context of what I was saying earlier. And if I just multiply it by 12 over 12, right, I'm going to get 24 over 3, which is 8. And I'm going to get 60 over 4, which is 15. And I can cancel out as well. I can take this 3 into here and get 4. So 2 times 4 is 8. I can take this 4 and cancel and get 3 and get 15. When you can do this numeracy way, it really is beneficial. As easy as it is to do the keep, change, flip stuff and so on, it's just convenient. If nothing else, use this for your part of your sanity check. Okay. And speaking of sanity check, just to throw that in as part of the discussion of this, if a recipe uses 2/3 a cup of sugar for every 1¼ cups of flour, and a cook wants to increase the recipe, how many cups of sugar are needed for each cup of flour? All right, so there's less cups. So the answer has to be less than 2/3. All right, so for that reason, C and D are just out of the picture completely. And then 5/6, that's close enough to 1. So I don't know that if it needs to be less than 2/3, it logically can't be 5/6 either. So you could have just logicked out this question and got through with it just using your mastery of just how numbers work and mixed fractions work and all these kind of things like that. So you have now 3 or 4 ways to solve a lot of these questions here of that nature. All right, let's see how we do it on time. Because I think that's the end of the rate and the proportion questions that they have here. There will be lots of rate and proportion questions on an exam. There always is. So let's see, we're 26 minutes. I don't really want to throw in. Wait, did I do 85? I may have skipped 85. I don't really want to throw in constant or proportionality here because I think that should be separate. Where's 85 here? No, I didn't do 85. So let's throw that in. That's probably amongst some of the hardest ones here. So a bus takes 9 hours if the mean speed, the average speed is 50 miles per hour. Okay, how many hours would this trip take if the average speed was 45 miles per hour? So this one, I don't know. Although there's definitely a rate involved here, it's not as straight up really as the others. So what we have is 9 hours at 50 miles per hour. Okay, so that's going to give us 450 miles. All right, now that we know it's 450 miles, right? We're going to divide it by the 45 miles per hour. And then we just get 10 out of that. All right, so the answer to that would be 10 there. This is a little confusing because it seems like we should be setting up something like 9 is to 50 as something else is to 45. But that doesn't work because that's talking about different comparisons. It's not saying it's 9 hours per 50 miles, right? This is 9 hours to go 50 miles per hour. All right, and if we go back to that distance equals rate times time thing, right? That's part of what we're doing here. So basically what we have is 2 distances. The first distance, we actually have 2 formulas, if you will. A first rate and a second time, and a second rate and a second time. Okay, and it just turns out the distance they each go turns out to be the same number. So basically what we're having is R1 times T1 is equal to R2 times T2. That's really, and so not the proportion, this is our equation. So we have is 50 miles per hour times the 9 is equal to 45 miles per hour times, and they're asking us how many hours. So they're asking us for T2, right? And at that point, we just divide both sides by 45 if we want. Okay. 9 goes into here 5 times. 5 goes into here 10 times. So we end up with that T, because this canceled out. T is equal to 10 again. So this is what they're asking us to do. The proportion doesn't make sense. You can't always just line those numbers up. And if you think it through, how are we setting up 9 hours compared to 50 miles per hour? They weren't asking us that, right? 50 miles per hour is a different rate than 45 miles per hour. So we can't really get that out of this question. Okay. Yeah. All right. So I'm going to definitely spin off the constant proportionality questions. And please please subscribe. Hope you all are getting something out of this channel and that are benefiting your test process and your approach to testing and your thought process into looking at alternative solutions, always focusing on the numeracy of things and just breaking things down into parts and using the sanity checking and the double checking and things like that to make sense of whatever you got going on here. All right, y'all, like, subscribe, set your notifications, share this, set comments, and always hit me up at GregsTutoringNYC at gmail.com. Peace, y'all.